All right, welcome back to the second half of this lesson. I think I titled the first one Cavalieri's Principle in 2D, and I titled this one 3D. Really, the first half of each of the last two, this last video and this one, are 2D and 3D. 2D and 3D, one's vocabulary definitions, and this one's more application. So the applied, I may retitle them, I may not. Life goes on. Okay. Consider the following right pyramid and right prism. Okay, right pyramid definition. Remember that the apex is directly above the center of the polygon shape, whatever you want to call it. Now, both figures have a base that is a regular pentagon. Regular pentagon. Each side is 1. That means each angle is 108 degrees. Our height is 2. Height is 2. Like we said in the last video, if I fill this up with water, 3 of them will fit in there. We can't really do that as well, graphically as you could with the cube like they did. Now, he said, or Heidi says, to use Cavalieri's principle to show the two figures have the same volume, or she tried to use to show they have the same volume. Okay, what was her first mistake? I think that. The base areas are the same, therefore corresponding cross sections have the same area. Well, no, they don't. That doesn't have the same area as that. Figures have the same height, so the volumes must be the same. Okay, first mistake might have been waking up in the morning. No, I'm kidding. Just finish that dream so that you have a little closure there. Base areas are not the same. Well, they are the same, so that's not actually a mistake. Okay, so that they are the same, but they're not. That's not a mistake. She didn't make that mistake. It isn't true that corresponding cross sections have the same area. That's true. The heights are not the same. Yes, they are. It says so. It says they have the same, whoops, there we go. It says the following, both figures have the same base, or have a base that's a regular polygon. They both have the same height. It didn't say so, but the 2 tells us that. So all that's left is that the mistake was, it isn't true that corresponding cross sections have the same area. Just pick one, and that disproves it. Done. Don't stress about it. Following figures have the same height and the same base area. Which 2 can we apply Cavalieri's principle to show that they have the same volume? So now this is a 3D one. Okay. Same base, same cross section, same cross section, same cross section, same cross section, same base, not same cross section. So A and B are our friends. So A and B. Done. No worries. Don't need to stress about it. Okay. Following rectangular based, triangular based, and triangular based prisms. Now this area is 6 times 2, which is 12. This is 6 times 4, which is 24, but it's a triangle, so we got to remember we cut that in half. So the area of these 2 bases is 12 for both of them. This has a height of 10. This also has a height of 10. They put the 11 there specifically to distract you from truth. Fake news. Okay? Fake news right there. Fake news in it. Doesn't matter. Useless information. Unless you're trying to find surface area. But we're not. Okay? So 10, 12, volume is 120 on this. Volume is 120 on that. So he tried to use Cavalieri's principle to show that they have the same volume. Base areas are the same, therefore corresponding cross sections have the same area, so the volumes must be the same. That's incomplete. Okay? That's like saying my ceiling is blue, so therefore the sky is blue. Anyway, the base areas are not the same. Not true. They are the same. It isn't true that corresponding cross sections have the same area. We don't know that specifically. He did not establish, however, that the heights are the same. If he had established the heights were the same, then we could have done that all the way up. I think he probably needs a little bit more, but this is the big part that's missing. All right, next one. Pyramid A is a quadrilateral base and a height of 4 units and a volume of 20 cubic units. Okay, the first one, A, 20 units cubed. And it's okay to put units, just U. But don't put U if they've already told you that these are meters. Okay, you can put cubic units, but if they already told you meters, then don't put cubic units. That's just wrong because you didn't notice that there was an M next to the 12, which there isn't now, so you're okay. But I see that all the time. People just always put units, the word units, instead of the actual units that are from the diagram. So 20 cubic units. Well, this has the same base. It has 3 times the height. The equations are identical. So if it has 3 times the height, it's got 3 times the volume, so 60. That's simple. Just common sense, which I don't know if it's very common anymore, as I think many people agree. Cylinder A has a volume of 6 cubic units and a height of 3 units. Okay. Cylinder B has the same base. So we're learning same base, same height, fake news, and this volume is 6. So what's this volume? 6. Done. I kind of don't like that they put it first because, you know, it's more easy to get distracted if they put it somewhere in the middle. But I see what they did. They just went in order numerically, you know, smallest, next biggest, biggest. Okay? Simple, simple. Next one, the following triangular prism has a volume of 10 cubic units and a height of 5. 10 cubic units and a height of 5. This looks kind of messy. But what they're doing is they're using this to show that the height of this is the same as the height of that. And the height of this is the same as the height of that. And these are both perpendicular to these planes, so that means it's an actual height. All right. So that being said, 7.5, its longest edge is 7.5. Doesn't matter. We've got an equation that is area of the base times the height divided by 3. Okay. Volume. This one's volume of 10, height of 5. So the area of this base has to be 2. Okay. Because the area of the base is 2 times the height is 5. That gives us our volume of 10 cubic units. Now, the triangular pyramid has a congruent base and the same height. Its longest edge is 7.5. Fake freaking news. Because all we need to know is it has the same base. 2, it has the same height. 5. So how do we find the volume of a pyramid? It's the area of the base times the height divided by 3, or times 1/3. And this is 10 right here. So we get 10 thirds for this volume. Not 15, not the same, none of that. Again, A is the answer. Don't like it, but we deal with it. Pentagonal prism, pyramid, sorry, has a base of 30 meters squared. 30. The height is 5, so its volume, pretty simple. Okay, we end up, oh, I got all this stuff already pre-written. I don't actually have to write it. Whoop. So we got the 30, area of the base, times the height, 5 divided by 3. Cancel the 3's from there. You get 10 and 1. 10 times 5 is 50 divided by 1. So our volume should be 50 meters cubed. Okay? 50 meters cubed. Done. So simple. All right. Now, don't forget here, area of your base. Your base is this. Okay? Any non-rectangle. And somebody might say, oh, this is not a rectangle right here. If you cut it out and flattened it, it would be a rectangle. This right here would be a rectangle, as would this be a rectangle. This is the non-rectangle. Now, it's a quarter of a circle because we got 90 degrees right there. A quarter of a circle. Pi over 2 radians. Ooh, last chapter. Bring that back. Quarter of a circle. So what we do is you just got to remember to say what it is you're trying to accomplish. I got a quarter of a circle's area, and then I'm timesing by the height. I don't divide by 3 because it's not a pyramid. So a quarter of the circle's area. And then I can move that out of the way. Quarter of the radius squared 4 times pi times the height, which is 10. These 4's cancel out. So I really just have pi times 10. Oops, get the rest of that out of there. Oh, can't I move that? There we go. 10 pi meters cubed. You can't say units cubed on this because there is an m. Anything down here? No? Doesn't look like it. Yeah, that's it. And our last one, triangular-based oblique pyramid. Oblique, remember, that means that it's just not right above the center. The height doesn't matter because of Cavalieri's principle. Remember that? One thing I also like to point out is when you're talking about base times height of the triangle that's on the ground, okay, that base is little b. If I'm talking about the entire triangle, you're going to talk about it as capital B, big B. Somebody's last name, I think. This height is little h. The height of the whole structure is big H. Okay? And the area of this base times our height times 1/3, or just divided by 3. Okay? So I've got 1/2 base times height, little base, little height. And then the big height corresponds with that, and then 1/3. Now, we can do some canceling, because what we have here, and notice these are all being multiplied. 1 times 2 times 3 is the same as 3 times 2 times 1 is the same as 3 times 1 times 2. It doesn't matter our order. We're still going to get 6 for that answer. So multiplied, 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 multiplied. It doesn't matter. I can jumble these around. So I can take this 1/3 and use it to cancel out that 3. I can take this 1/2 and cancel out this 4 and make it a 2. Okay? Now, oh, funny. I didn't even put the height in there. Oh, we're looking for the height. Ha! I'm like, I didn't put the height in there. Why did I put the answer already? Because they told us the answer was 13. The answer is 13. We're solving for this. So now what we've got is what happens when you do these the day before. Oh, what happened there? Yeah. Because I've got 2 heights is equal to 13. So 1 height is 13.5. Best answer, but the multiple choice might be 6.5. Know that those are interchangeable. If this ends up being a decimal that goes on forever, a non-repeating, non-terminating decimal, leave it like this, unless they ask for you to round, okay? Unless they're talking about how many cans of paint do you need. Well, the answer to that would be 7, okay? 7 cans of paint, because you can't buy half a can of paint, and it's not even financially responsible to do that. So there we go, applied Cavalieri's principle. One more set of lessons coming up, and then we are done for the year. Have a good day.